Gabriela Vasquez and my team members Jennifer Aniela and Daniel Giraldo, and we are bug breaking underground. And today we're presenting an inspection device for Hanford site Department of Energy underground tanks. Retrieval of radioactive material produced vast quantities of high-level waste. This high-level waste is stored in double-shell tanks, and this double-shell tank consists of a primary tank resting on a refractory pad that has refractory slots that work as cooling channels, and a secondary liner tank to prevent leakage. In August of 2011, waste material was found in the annulus between the primary and secondary tank, and so the origin is believed, and you can see this waste right here. The origin is believed to be a break in the primary tank, and the waste is traveling through the cooling channels to the annulus. Our motivation, first and foremost, is environmental impact. Obviously, this waste, if it leaks into the subsurface soil, can continue into the Columbia River and affect the ecosystem and communities that use this river as a water source. Our second is that this application will be globally applicable in the sense that all developed countries that produce high-level waste need some means of storage, and this means of storage needs to be inspected periodically to prevent leakage. And so our objective is to develop an inspection device that essentially will travel through these cooling channels to find the source of leakage, and it will provide video feedback to the site engineers so that they can see the tank conditions.
The design parameters of this device include that it has to be deployed through risers to the annulus floor. It needs to travel through 1.5 by 1.5 inch channels. It needs to navigate through 4 90-turns elbows. It needs to be remote control, as well as it needs to provide video feedback. It needs to be radiation tolerant at 85 radians per hour. It needs to withstand also a high temperature of up to 170 degrees Fahrenheit. The device must not be subject to channel walls to pressure greater than 200 psi, which it is the yield strength of the material. And it must have a tether for means of power supply and retrieval. The contractor at Hanford site identified vendors such as Arriva, Vista Engineering Technologies, and IHI Southwest Technologies, Inc., to develop off-the-shelf technology that can maneuver through the pathways and provide visual feedback to the factory pad conditions. Vendors demonstrated the approaches to be used. However, for different reasons, the contractor did not provide continuous support to the efforts. The devices that were designed could not travel through vents, did not protect the refractory, and were of high cost. The frame of our design was designed such that this small device can carry a camera, take video feedback without destroying the refractory pad, and is able to turn at the vents. The design will contain a magnetic plate that will be attached to the top of the carbon steel tank, and also the device will contain a tether that will be giving power to the motors and the camera, and it will be used as a means of retrieval in case the device fails.
Now, the major components of the crawler, inspection crawler, are divided into two divisions, mechanical and electrical. On the mechanical side, it's going to have the bearings, gears, the tank tread, the wheels, the shaft, the magnetic plate, and the frame. On the electrical, we have a fiber optic tether, which will be used as a communication line to the lab view controller to the camera. And our power cable goes directly to the speed controller, which is going to control the electric motor. Now, the speed controller is very important because it allows for a smooth and precise variation of motor speed, which would eliminate the jerk, which maybe it can fall from the top of the tread. Now, worldwide, 2.6 million gallons of high-level waste is generated each year. That's a lot of waste. That's waste that goes in, needs to be stored in a tank, and a tank that needs to be inspected periodically, hopefully by our problem. Countries are working with research companies and combine effort to develop radiation-tolerant robotic devices. Research devices, such as the one that Jennifer mentioned, that Francis Arriba Sea Snake, are referenced for the development of our inspection tool. There's no need to reinvent the wheel. Global application, the user manual is going to be available in English, Spanish, and French. Now, if it goes worldwide, then it'll be printed in Chinese and all the other languages needed. Our power supply is 12 volts DC current, and it'll have a rectifier with 110 or 240, since we can't come up with a standard worldwide. Our team assignments are systematically divided so that each, or our teammates' abilities were put to use, and so that each person had equal amount of work. The timeline has been followed rigorously, and hopefully during the summer we'll do the prototype construction and testing, which will go into the fall, and we can present the design to you in December.
And so finally, as we move forward, like Danny mentioned, we hope, we have an estimated cost analysis of close to $10,000. And that has to do with the components at $7,600 and the labor cost at $12 per hour for, at $2,800. We hope to have the design validated using an FAA analysis on Abacus software and obviously continue testing. And so we'd like to thank our mentors and the DOE FIU for their support.
Thank you.
Do you have any questions now? Yes.
I have a couple of just quick questions, kind of comments also. There's a couple ones. So the design parameter slide, maybe 4 or 5 in. Keep going back. Keep going back. Keep going back. A couple more. Sorry. Yeah, that. I can't tell what that is at the bottom.
So this is the actual refractory slot. So this is what the primary tank is resting on. And so these are the channels. There's 72 entry slots all around. And then these are the dimensions. So it's 1.5 inches by 3 closer to the center. And then 1.5 by 2 inches in the middle. And then 1.5 and 1.5 by.
So what I would say maybe the best way to do it is just draw the path that you're going to take one time through. You know, maybe it just becomes very, very tough to see, you know, what you guys are, the actual paths that you're doing. You know, so maybe it doesn't have, you know, just in SolidWorks or something, just draw kind of a path that you would take.
Like 290-degree turns.
Yeah, so then just say that, and it makes it much easier to understand.
Okay.
And then the second thing with the design dimension. So, couple forward, one more. Yeah. So right here, it says its small size allows it to turn on vents. You can probably give us some of those dimensions. So give us the dimensions of the channels and of your device, so that way you can see that it actually will fit through those different openings. Can you go to the global applications? Just, I'm not a huge fan. Go back one, actually. I'm not a huge fan of the. I know sometimes we do this in the past. I'm not a huge fan of like the manual things. You guys have really great global applications, right? I mean, nuclear waste in everyday drinking water is terrible, right? So your global applications would be, hey, we're going to try to find a way to inspect tanks and have a device to inspect these tanks that is radioactive repellent. You know, it's resistant to radioactivity and all of that. So this can be used all over the world to inspect different sites for nuclear waste, which things like Japan or whatever. Your device may be able to be used in a reactor that goes down that has small cavities or something like that. So maybe that's a better way to say you have global applications, right? I mean, this stuff you can include, but I wouldn't specifically state like, hey, our user manual is available in several languages, because you're not going to do that. You know, you guys aren't going to make like a Spanish user manual for it. So try to kind of incorporate that a little bit. And then one other thing, I know you guys have magnets on the top, right?
Yeah.
It might be worth just stating how the device actually crawls through the channels, because the other thing is on the bottom of all that is a bunch of garbage, right? So you're going to try to use a magnet to connect to the top of it. So just state that, that's your, because that is the real novelty of your design.
Yeah.
Is the fact that you're going to attach to the top. So just show it doesn't have to be the final design or anything like that, but
Okay.
you're saying how you're not, solving it. Okay.
Thank you.
Okay, on that first slide, would it be, I like your suggestion, but it seemed that they've invested a lot of time and effort already in that. Could they put that by itself on another slide? I just have a.
Sure, absolutely, yeah. I mean,
Or maybe
it's
outline
just-
it on
Well, go
that.
back.
Yeah, right, so you can have that same picture, but just have the channel there so that we can see, like, this is the path that you're taking, because otherwise, it's just tough to see.
Yeah.
Yeah.
Any other questions? Thank you.
Well, we should tell them that the purpose of the slide will go over the minute.
Yes,
So,
we won't be using this.
Is
We're
that
just
what it
gonna,
is?
yeah,
Next
it's
slide, I
difficult to
think.
go to
Next
the next
slide, yeah.
slide, so it's just